Welcome to the 3D printer lab, ideal lab, whatever you so may choose to call it. This is in the back of the library. You can ask any librarian where it is, where the door is. You can come here anytime you want, any time of day. These are our 3 Ultimaker printers. Nothing too special about them. This is the Dremel, new this year, and our MakerBot. I would recommend printing on this Dremel or this Ultimaker. This printer is mine. It's not for public use. I just keep it here because I'm too lazy to print at home. If you want to print, you first need to find an SD card. Take one out of the machine, as there are usually them in here. Put it down on your desk and sit down at this Apple computer. Choose the Ideal Lab little icon and click it if the mouse works. There is no passcode. If you have to enter one, hit the space bar and hit enter. This computer is slow, so be patient with it. A lot of stuff in here is slow, but that is something you will learn. Okay, you want to print something. These printers have a 3D software that converts 3D models into instructions to be sent to these printers. The bed on this does not move, it only goes up or down. These printers run on an XYZ axis of this extruder. It moves in every direction imaginable, thus creating a 3D model. These use hot plastic. It is heated up in this extruder and extruded layer by layer according to the instructions your file gives it. The filament is on the back of these. Please do not change the filament without asking someone if they know how. If they sound concerned, don't go through with it. Just wait for me or Rohan to come here and we will help you out. These printers are very finicky. They print on a glass bed which is heated depending on what kind of plastic you use. We keep our plastic in this drawer right here. There are a couple of different kinds. We have carbon fiber, some mixes of PLA and ABS. The most common one, probably the best one in my opinion, is ABS. That is what you get if you get takeout food, and they're in little clear plastic containers. These are called Fdm printers. These fuse direct plastic onto each other and it builds it up layer by layer. You can select that layer height depending on how clear of a piece you want. So we're going to print on this printer as an example. Now to get an Stl file, go to the internet, type in Thingiverse, it should come up, it's autofill. This is heaven. This is where you find every STL imaginable. So let's say I want to print an owl. There's a little search bar, type in what you want. There's also a featured section where you can see what the latest and hip cool trends are in 3D printing, if you're into that. You will go to Thing Files, and this is an STL, see the .stl. If you find something that isn't too common of a thing to print, there's a little section here that says made. If no one's made one and posted it, I would not recommend printing it, because that means no one's printed it and it's probably turned out successful. But you never know, maybe someone did and they just didn't want to post it. Go to Thing Files, click this, and it will start to download. Get out of full screen, go to your downloads section, and well, there's the owl up there. You will drag this onto the desktop and place it there. Close Safari and open up this right here. This is called Cura. It is what creates G-code, which is what sends instructions to the printers and tells that extruder to move in a certain series of patterns to build a model over the course of a couple hours. These are slow. These do not print in minutes unless you want to create a giant ball of mess. Like I said, these printers are very, very finicky. You, most of the time, will not print something and it will go perfect the first time. You will have to try it again, which is why if you want to print something, I recommend coming in here after school, during lunch, trying it, watching it fail, getting sad, trying again and not getting sad, because hopefully you'll have learned and you will have updated the way you printed it. This is Cura. This box right here is a little 3D render of the max dimensions you can print a piece in here. See, that's how this says Ultimaker 2 Extended Plus. That is for this printer right here. It's our largest printer. I would not recommend using it. It has always had issues. Try and stick to this, the Ultimaker 2 Plus or the 2. These are the same exact thing. Don't worry about the plus sign. So, to change that, like if somebody changed it to this, like it is now, if you want to change that to the printer you want to print at, up here, it says 2 Extended, click it, and hit 2 Plus. And it will change the dimensions to the correct size of that printer. So, to load the model in here, slide this over, find your owl, and simply drag it on and drop it. Most of the time that works. But like I said, this is slow. See, it's loading. This is made by Apple. This is the owl. I probably would recommend scaling this down, just because, I don't know, I just want to. Up here, you have this is the move. So you actually don't have to type in numbers. You can just move it however you want to with the mouse. Just left click it and drag. This is the scale. So again, you don't have to type in numbers. That's if you want a specific scale factor. You can pick any one of these axes and drag it down to make it smaller. That's too small. That's a good size. This is the rotate model. So this model has a flat bottom on it. That means it can adhere to the build platform very, very easy. If I was printing something else that did have a flat side, but not as good as this, I would have to orient it in a way that I think would print the best. I can't stress enough on these printers that getting a good, solid, flat base produces the best prints. So this base right here is a rectangle. It will adhere very well if the temperature is right. And about temperature, these printers heat up. The bed heats up and the extruder heats up even more to melt plastic and extrude it down through this nozzle. That nozzle hole is very tiny. It's what creates the detail that you can pop out with these things. So, I think we have PLA inserted on here. I'm pretty sure I'm gonna find out as soon as I start printing. Right underneath where you selected the printer, there's PLA. This nozzle should never change. Do not worry about that, and do not worry about this. This is a 0.15 millimeter setting, so that means every layer the printer builds up. As it goes up, each layer it does is 0.15 of a millimeter thickness. That's a pretty moderate amount of detail. It's not perfect, but it's not crap either. You can also change that by going to layer height and changing it, but I probably wouldn't. This shell is if you were printing something hollow. So we're not gonna print this hollow, so don't worry about this. It's a good setting overall. This is infill. So as the printer builds it up, it doesn't make it solid unless you wanted to, but that's a complete waste of plastic, and I wouldn't recommend it unless you just don't like me and you wanna waste it, but okay. You can change the density. This is at 18%. That's pretty good. It gives you enough strength. A common misconception with pieces is people think if you print it solid, it's gonna be the strongest piece possible. That is not true at all. If you print it solid, it therefore becomes more brittle because there's no support on the inside. The way that infill fills is this hexagonal pattern. You can also change the way that is, but I wouldn't because it's already very strong. It's good for ABS, which is PLA, which is what I hope this is. The difference between these two plastics I've been mentioning, PLA and ABS, PLA has a lower melting temperature, so it can melt easier without heating up as much. The bed does not have to be heated up as much. The printer, the slicer program might put it on for you, and again, that might cause issues, so you might have to manually turn it down. I'll talk about that later. But PLA is more brittle and it breaks easier, so it doesn't flex as much. So like if I printed something very thin, like the size of a pencil, it wouldn't bend enough before I broke it. ABS is the opposite. It bends a little bit more before breaking, and it has a higher print temperature. That means the bed has to be heated up more, and the extruder goes all the way up to 210 degrees Celsius, which is extremely hot. Don't touch it. I've done it. It doesn't feel good. Back to the slicer. Your infill set. Do not worry about this enable retraction. It's just pulling the filament back out every time it does a layer. Don't worry about it. This print speed, if you're absolutely desperate to print something, then you really need to find more time to sit and watch. Don't really mess with this. The printers are not fast printers. They can print in a very decent time. My print over here is meant for speed. These are just meant to print something in whatever time it thinks is necessary. Cooling, that is the fans. Leave that box checked. Now support. This is where things get a little tricky for some people. You have to imagine the way the printer is building up something layer by layers. If it's building stuff up, it can't create a 90-degree angle. So like I said, this flat base right here, if that was in midair, it would never print that. Because the filament, when it comes out of the extruder, it hangs out. So this is just my extruder hanging out. But as it's printing, if it runs over something and starts extruding filament, it'll just fall. And you'll create this giant spaghetti angel hair looking mess. You do not want that. So this is curved, and it can take curves. It cannot take 90-degree angles and flat sides. So if you were printing, for example, this Eiffel Tower right here that somebody printed, these straight overhangs, these printers do not do that well. The Dremel does, but these printers do not. It cannot handle that 90-degree flat side right there. These cross beams, however, it can, because it's a shallow enough angle for the extruder to be able to build plastic on top of each other. Cannot do that with sharp angles. So this owl, the slicer will highlight red marks for you that it thinks it might not be able to handle. Now, the good thing about these printers is the support doesn't really become an issue. It's sometimes hard to take off, sometimes it's not. It just kind of depends on the way the printer wants to print it. And you are gonna probably have to put support on a good amount of things you print if they're as complex as this. So, generate support. Of course, Apple's frozen. I'm gonna go ahead and put it on because I'm worried about this back angle over here. Like I said, Cure is slow. It freezes a lot.